Hello, thanks for joining this session. Please leave a comment if you can hear me. Okay, cool. So today we are going to talk about an interesting topic like just clone and run developer experience using test containers. So why do we need to talk about this developer experience, right? So have you ever been working on a code base that have been maybe 7, 8 years old or even more? And then have you ever felt the pain of setting up it locally? It may take days, even sometimes it may take weeks because there are so many things to configure, install before you are able to run your application locally. So I had those experiences in the past. When I join a new project, sometimes if I'm lucky, there will be a README file or somewhere in the Confluence documentation that says, okay, first clone this repo and then you need to install so XYZ softwares and then you need to unpack some tool into so and so folder and then go into some directory, open this XML and configure all these properties. So there will be a number of steps that you need to do before even you are able to run your application. If you are lucky, you will have such documentation, and sometimes we are not so lucky, so you will have to figure out what are all the things you need to do before running your application locally. That's a thing. And even worst thing is sometimes whatever the documentation that is there, it is outdated or it is not updated in the recent times. So you will have to you assume they are correct steps and then you proceed and then you realize they are not updated. And again, you have to follow up with the fellow team members and it's not very pleasant experience. So fortunately, in the recent years, we have better tooling support, and we can make it not so painful. We can make it better, and it should not be that hard. So I'm going to talk about how we can make things not so painful, especially by using test containers. And we are taking an example of Spring Boot application here. But whatever I'm going to explain is kind of equally applicable for other frameworks in Java, and also we have support for other languages as well, like Go. I'm going to give you some references for you so that you can reference it later. Okay. So what we are going to do in this session is first, we just talked about what are the challenges we usually face. Especially nowadays, we are building applications that use a wide range of services like there is SQL databases, NoSQL databases, and message brokers and search engines. So there are so many tools that you might use, and installing all of them is configuring them is kind of a very tedious process and uh, and also you should do a proper testing. Fortunately, we have test containers which can help very much in that aspect, that can help you to test with the real dependencies. And then you have the challenge of how do you able to run your application locally. So in the recent times, again, I am saying taking an example of Spring Boot, but this is kind of equally applicable for other frameworks like Micronaut or Quarkus. But we are going to take an example of Spring Boot. So in the recent Spring Boot 3.1.0, they have added support for local development using two different approaches. One is Docker Compose, another one is test containers. And we are going to take a sample application and then see how we can leverage test containers. And also we'll take a quick look at how we can use Docker Compose as well. and talk about what are the pros and cons of the two approaches, and then we'll see a demo how we can run the application. Okay, and also we are going to take a quick look at what is Testcontainers Desktop, and quickly go through what are the features offered by Testcontainers Desktop. So this is what we are going to do now. So do you have any questions so far? Okay, so if you have any questions, please ping in the chat. And I'm going to move this to a different monitor so that I can keep a look at both the code base and then comments. So I hope you can still see my screen here. And okay, here is a sample application I have. Let I'm going to make it public. It is private right now. I am going to make it public, and so that you can explore yourself also. So here we're going to take a look at this sample application where we have a simple Spring Boot application that stores the product's information in our Postgres database. And also, there is a Kafka topic which we listen to, and then we receive messages regarding product price changes, and it will consume those messages and then persist those changes into our database. So here, just for a demonstration purpose, we have only two services that we are interacting with. Don't see the IDE. So sorry. So here I am showing this. Okay, sorry. So I am showing this in my browser itself, not IDE. So can you see this repository that I am showing? Okay. Hmm. Okay. Can you see my screen now? The repository. So currently I am showing you. Yeah. Okay. So this is the repository I was talking about. This is nothing but a simple Spring Boot application, and here we are talking to this Postgres database to store the product's information, and also we are listening a Kafka topic, which product prices information will be published, and we are consuming those messages and then update the data in our product database. So this is a simple Spring Boot application. Currently, we are only integrating with the two services: a database, a Postgres database, and a Kafka. So usually there could be more such services that your service might integrate with, like there could be a Redis cache, there could be a Elasticsearch for search functionality. So there can be more integrations. So here, just imagine if you want to clone this repository and then you want to run the application. Usually, if you don't have any kind of a Docker support, you would have to install Postgres and then Kafka and whatever is required, you need to install all of them. Okay, so here now by using test containers, you don't have to install any of these things. Right now, you can right away clone this repository and then simply run just like this. Just clone it. And if you want to run the test, you can simply run the test. And for writing tests, we are using test containers. And also, as I said recently, Spring Boot 3.1.0 introduced support for local development using test containers. So we'll see how to set up, but simply you can run this command, which will automatically spin up these required containers, Postgres and Kafka, and automatically configures your application to talk to those services, and then starts the application. Or if you want to debug, you can look at this test application and then run it, and it will start all these services and starts the application. So we are going to take a look at it. But before that, Are you familiar with test containers? So, so have you heard about test containers or have you used it or is it the first time you are hearing about the test containers? So if you haven't heard or used test containers, this is a testing library which is available, by the way, in many popular languages. Like, right now, you can see it supports Java, Go, .NET, Node.js, Python, Rust, all these most of the popular languages. So how test containers helps is, as we saw, so in our application for writing an integration test, you need to have a Postgres database and a Kafka instance, right? So um, test containers helps you to automatically spin up these services as Docker containers, and you can configure your application to use them on the fly and then run the tests using these services. Once the tests are done, it will automatically cleaned up. I mean, test containers will take care of destroying these two containers, and then your tests will be done. So you don't have to do any manual setup or prior starting of the containers, nothing. You simply run your test using test containers, and they are going to use the real services. The benefit is usually if you see in Spring Boot application, one of the common and bad approach is if you are talking to a database through data JPA or whatever JDBC, sometimes people use H2 because it's easy, it will automatically configure, you don't have to do anything. But the problem is your test, if you use H2 and use a different database in production, there is no guarantee that it will work exactly in the same way. Whatever the test you write, that may pass, but when you actually talk to the Postgres database or Oracle, whatever you use in production, that may fail. So obviously your tests will be not very useful, right? So in the same way, like you can use embedded Kafka. I don't know whether it is supporting right now. Earlier there is an option embedded Kafka and you can use it. But with test containers, you don't have to use any of these things. You can use a real Kafka instance, a real Postgres instance, so that you have more confidence that if the test passes, it is going to behave exactly in the same way in the production also, right? So that is a benefit of using test containers. Now, before Spring Boot 3.1.0, there was support. I mean, you can still use test containers for testing, and you typically used to do this kind of a configuration. So you can write using your Spring Boot at Spring Boot test an integration test, and then you can annotate with at test containers, and then you define whatever the containers that you want for your application. In this case, we have only Postgres dependency, and you define it as a container. So it will automatically start this container, and then you have this dynamic property source mechanism where you register this Postgres JDBC URL and username into this Spring data source properties. So with this, when you run this test, it is going to spin up a Postgres container and your Spring Boot application is configured to talk to that Postgres database, and then your test executes. So that is fine for testing support. But still, if you want to start your application for local development, not for tests, you still need to rely on other mechanisms. But with Spring Boot 3.1.0, they have added support and even made it simpler to use a concept called service connection so that you don't have to write this boilerplate again and again. Instead of using this, you can simply add this Spring Boot test containers dependency and then add service connection. So Spring Boot is going to figure out, okay, start this container and automatically register these data source properties with Spring Boot application so that you don't have to use this approach to register the properties explicitly. So it is kind of for testing, it reduces the boilerplate and make it easier to use. But it also adds support for local development as well. So here, what you can do, you can create a class. Here we call it as containers config, and you can define bean methods, which returns what are the containers that we want to use. In our case, for our application, we want a Postgres container and also a Kafka container, and we register them as beans. And also we can add this at service connection. So that again, in the same way, it is going to register these properties and start these containers and then register these properties with the application. So how do we use this configuration? So earlier we have seen, right, in our controller test, we define all these required containers like this, but there could be a number of integration tests. So instead of repeating all this configuration, you have a test configuration class in which you define all your container dependencies, and then simply you can import. So in any of your integration tests, you can simply add this and it is going to work fine as if you defined all these in each of the test classes. So you don't have to repeat all these container definitions. Okay, so this is all simplifying this for testing. But then how about running the application locally? So now if you go to, I think we are all familiar, whoever work with Spring Boot, they are all familiar with Spring Initializer, right? So here, if you try to create an application, right now I already selected Spring Web, Spring Data JPA, and Postgres driver. Right now, for local development, there are two approaches. As I mentioned, there are two approaches, Docker Compose and test containers. So if I go to this and then add Docker Compose support, and if I try to explore, so here you can see it creates, first of all, it adds this dependency, um, Spring Boot Docker Compose, and also creates compose.yaml file, and it will automatically configure this Postgres database with some predefined properties. And if you notice, the port is only configured 5432, it is not mapped to any port on the host. So when you start the application using this, it will automatically spin up this container and then auto configure these properties as Spring data source properties, and it will automatically work. Behind the scenes, it starts up all the containers that are defined in this compose YAML file and register them. If they are known to the Spring Boot Docker Compose support, it will automatically configure them and then start the containers. But the limitation is right now, if you take a look at documentation, here in the Docker Compose support, we have a limited set of containers support. Right now, if you take a look at it, there is no Kafka support right now. There is no Couchbase support. Whereas there is other option where instead of using Docker Compose support, if you add test containers and if you try to explore, here you can still see in pom.xml, instead of Docker Compose, you have this Spring Boot test containers dependency, but your container dependencies are configured here in test demo application. It is configured as a bean. And the good thing is, if you add Kafka, okay, so now if you go to your source code and explore it, and here, if you see, in addition to Postgres, Kafka container is also configured with a service connection support. So there is more container support, out of the box support. And even if there is no support from Spring Boot, you can still use any container that is Dockerized. There is no limitation. I mean, technically, you can still use Docker Compose, but the thing is, it will be split up like some are here. If you see Compose, it is not adding Kafka image because there is no out of the box support. So I want to have a unified experience. For example, anyway, in our application, we are going to write tests using test containers. So then why can't we leverage the same configuration for both local development and tests as well, right? We don't need to configure in two different places. Right now, if we want to use test containers for testing, and use Docker Compose for local development, you need to kind of duplicate container definitions in two places. And again, there is no out-of-the-box support for some of the containers. So my personal preference would be to rely on test containers where you can define all of your containers. So now let us take a look at our code base. So I cloned the same repository here I talked about. Okay, and here I have opened the project in my IDE and nothing major. Here we have Spring Data JPA, web validation, Kafka, and PostgreSQL, Flyway, and we have Spring Boot test containers, and we have test containers Kafka module, we have test containers Postgres module. Okay, so these are the dependencies we have. And as I shown in the blog post, we have containers configuration here. And in the containers configuration, we have defined a Postgres container as a bean and also annotated with service connection, and also defined a Kafka container as a bean and also added service connection. So now for writing integration tests, I can write a Spring Boot test and also imported this containers configuration. So all those containers will be automatically started and also registered with the application. Now here in our product controller test, we are making an API call and then asserting the response. Okay, before that, let us quickly walk through what do we have here. It is very simple Spring Boot application. We have a JPA entity, ID, code, name, and price. And we have a simple product repository, and that contains a couple of custom methods: update product price and find by code. That's it. And we have a simple product controller, and we have only one API endpoint to get the product by product code. But we also listen to Kafka topic, and here we listen to a topic named product price changes, and we receive this payload product price change event, and then we are updating the product price. So it is as simple as this one. We receive a product price information updates as an event, and then we update respective product price here. Simple. And we have an API which anybody can invoke and get the product details. So here, this is the code we have. And when we talk about tests, here, product controller test, and what we did before running our test, we are creating a new product and persisting into the database. And for that, we are trying to fetch for the code, and we are asserting whether we received the response or not. So it's a simple API test. And then we have a Kafka event listener test where we are using Kafka template. And again, we are creating a simple product. And then we are sending an event to Kafka topic with the newly created product code and a new price. And then we are using Kafka template.send, and we are sending that event. So it should ideally consumed by our event listener and then update the price of that particular product. So here we are using awaitility, and then we are trying to get that product details and then comparing whether we get the same product code and whether we have the new updated price in the database or not. So here behind the scenes, because we are importing this containers configuration, when we run this test, it's going to start both the Postgres database and Kafka container, and then run this test using them. So let me quickly start it. So here you can see it started both containers using test containers and then executed the test. So this is how you can tackle testing using test containers using real dependencies as a Docker containers. But how about running the application locally? So as I said, in the recent Spring Boot 3.1.0, they have introduced this new support where under src test java, you can create a class with a main method, and then you can start from the main application class and also add your container configuration class here with containers configuration. So instead of running this application main entry point class, which is there inside src main java, we can create our test application, and you can name it whatever you want, and then from main application class and also add this containers configuration. So now instead of starting this application, if you start this test application, it's going to start the containers defined in this class and then start our application locally. So here I'm starting this. If you see in the console, it's going to start both Postgres. Let us see. So now when I run Docker PS, I can see Kafka Postgres instances started and the application is started. So here, if I go to Postman and then see, I can invoke the API endpoint, which means it is working fine. Okay. So that is how simple it is. Right now, what you can do, you can simply clone this repository, and you don't have to do anything extra like okay, start this before running your application. There is no before running application step. You can right away clone this, and you can run all your tests using simple MEN test. Or if you want to start the application, one approach is, suppose you want to start the application in debug mode, go to this test application and start it in debug mode. Or if you want to start it from console for whatever reason, you can go to console. And if you remember, Spring Boot provides uh, a command like spring-boot:run. This is going to start the Spring Boot application using main entry point under src main java. But we want to start the application using test application, which is there under src test java, right? So instead of using Spring Boot run, you can use Spring Boot hyphen test hyphen run. And it is exactly going to do what we did, like running this application. So here also it is going to start those containers and then start the application here. So now Postgres is up, Kafka is up, and your application is started. Now I can again go to this and invoke the API endpoint. If I change, so it is changed. So that is how you can leverage test containers for having this wonderful experience of, you don't have to do any pre-setup. You can simply configure all your application dependencies using test containers. And the best part is you can reuse the same code, same configuration you have in your containers configuration for running tests as well as for running the application locally. So you don't have to maintain two different sets of configuration in this approach. So is I would take a pause here and see if we have any questions here. Any questions regarding what I have shown so far? Yeah. So this is one of the benefit. As I said, there are multiple approaches where you can use test containers only for testing and Docker for a local Docker Compose for local development. But in my opinion, it's kind of a maintaining two sets of same configuration. So and also you have more programmatic control by using test containers API, and also you can use any uh, any containers, and you have more programmatic control over there. Is that new annotation only replacement for contributing the configuration? it kind of acts as I mean, depending on which context, it can be for testing or development. So basically, what this service connection does is instead of using properties configured in application properties file or YAML file or from environment, this takes precedence and then register the beans because Spring Boot knows about this particular service connection. But yeah, does test container support any other containers like Podman? Excellent question. So yes, uh, now let me talk about uh, test containers desktop. So as a this is what we have seen so far is one step towards pleasant local development experience. And then test containers recently provided this test containers desktop where you can download the installer and then install it. Right now I have installed in my Mac. And here, if you take a look at it, right now in my laptop, I have both Docker desktop and ARB installed. So here using test containers desktop application, I can switch to any container runtime. Like right now, it is showing ARB and desktop Linux. Desktop Linux is nothing but desktop or Docker desktop. Sorry. So uh, are you able to see the Docker desktop that I am showing? Oh, sorry. I think I am not presenting the screen. I'm doing the same mistake again. Okay. Sorry about that. I forgot I stopped. Okay. So recently, Test Containers Desktop provided this Test Containers Desktop application. And here you can download the installer based on your operating system. And I have downloaded the application and installed on my Mac. And here it shows all the options that I have currently installed on my laptop. Here I have Docker desktop and then ARB stack install. So I can pick which runtime to use for running the test containers workloads. So I can switch between any of these two, or I can even use test containers cloud. Basically, all the containers that are going to start will be started on the test containers cloud environment instead of on my local. So you have the option to switch between any of the container runtimes that are there on your local, or you can run on test containers cloud. So does that answer your question, Harshvardhan? And Podman, yes, if you have Podman installed, it's going to be detected and shown in this menu as one of the option. Mm, any other questions? Okay, let us explore few more features from test containers desktop. Okay, so if you let me quickly make it public so that you can also check it out. So you can check out this repository. I'm going to add it into the video description as well. So here at the end, I have added some of the references links. One of it is this blog post on Atomic Jar blog, where it talks about what I just shown you, like how to use this Spring Boot 3.1.0 onwards support for Spring Boot test containers, and how to use it for local development. And also There is another blog post reference I have included. It's a guide on testcontainers.com. Here you can explore various test containers desktop features where, as I just shown, you have this option. Once you install, it will automatically detect what are all the container runtimes that are installed on your local and shown in this submenu. And you can choose which one to use. And there is another wonderful feature, my personal favorite, is using fixed ports to debug development services. So here, when we start the application, right, as I said, okay, let us go to here. So we have started the application and both Postgres and Kafka containers started. But what if I want to connect to the database to see some data? For example, I have performed some action. I want to check in the database whether the values are updated properly or not. So what we can do, if you take a look at this blog post here, it will show what needs to be done. Like in Test Containers Desktop, go to Services and open config location, and there is a postgres.toml file, and you can configure like this, which says container port. In the case of Postgres, it is 5432, right? So we are mapping containers 5432 port onto local 5432 port, and you can specify what images to be used for this configuration. So if I go to this test containers desktop and services, open config location, here there are examples for various services under which I have this Postgres toml file. Here I have the same configuration, containers 5432. I want it to map it on the host 5432. So with this configuration, because I have already started the application, what I can do now, I'm using this IntelliJ Ultimate database browser, or if you want to use any other client, you can use it. So here I can use this to connect to that database. So we have used a default Postgres. Okay, let me quickly show. So in Postgres container, the default user is test, default password is test, and database name is also test default. So we can use these properties to connect to that database. So here I can use test, test, and database is also test. So it is connected, and I can see the data here. You can see the schema and database here. So this is how easy it is during the local development. You can map the containers both onto your local, and there are examples for most of the commonly used containers like Redis, RabbitMQ, Oracle, MySQL, MongoDB, LocalStack, Kafka. So most of the commonly used containers, there are examples. You can simply remove this .example suffix and then configure accordingly, and you should be able to use any of your clients to connect to those services. That is really handy during the development. Usually, while running tests, you shouldn't be relying on fixed ports, but during development, this comes very handy. So that is one of the test containers desktop features. And also you can freeze containers. Suppose you are running test and it is failing for some reason, and you want to debug the container, what went wrong with the container startup or something. So you can go here and select this freeze container shutdown. So it is not going to immediately shut down the container, so that you have the time to inspect what went wrong with the container, and then you will be able to figure it out. So that is one other feature of it. And another one is enabling reusable containers. So during the development, you don't want to stop the containers and restart the containers every time you make change, right? So what you can do, you go to is test container desktop, and then you can under preferences, you can enable reusable containers option. And then in your code, this is usually a two-step process. First, you need to enable this option globally, enable reuse containers. And then here in the code, you can use with reuse true. So what does this do? When you run this application, it's going to start this container, and assuming if you don't enable this option, when you stop the application, it's going to be destroyed automatically. You don't have to do anything extra. But during development, typically you want to keep these services running so that you make changes and then restart the application. So you can enable this reuse option and you can just stop it, and it won't automatically delete these containers. So they continue to run. Okay. So during the local development, that becomes very handy so that you don't have to spend more time in restarting the containers. So yeah, I have added the links to that guide as well. And whatever I have described, these are not specific. I mean, using test containers part is a kind of a applicable for Quarkus and Micronaut as well. In fact, they out of the box support running these containers. If you add some JPA or Kafka, they Quarkus or Micronaut identify you are using Kafka or Postgres or whatever, and then automatically start those containers. So using test containers, it will simply bring this just clone and run experience without having to do any external configuration. It's not only for Java, it is also, as I said earlier, Test containers is not just for Java. It supports a wide variety of languages, and different languages support this local development in a different way. For example, here I have another video that explains how to bring the same local development experience in the Go applications. So I have a link to this as well. So if you are interested how to use test containers with Go, for local development, you can check out this video as well. So uh, that's about it, and we can talk about if you have any questions, we can have. So this is a good question. How do you differentiate if you have multiple projects, multiple DBs? So you can customize this. You can use with database name, and you can provide a different username and passwords, and they will be treated as different databases. And about connecting from tools to that database, uh, there is still work in progress how to support multiple databases or services mapping to the host. So the work is in progress. I think sooner the support will be there. Right now, it is kind of a mapping to only one container. And another feature, like one of the benefit of this reuse feature is, for example, you are working on multiple microservices, and let's suppose you have a RabbitMQ or Kafka like service which used by multiple services. One service will send messages to Kafka, another service will consume those messages. But here, during the development, you need to use the same instance so that both of them talk to the same Kafka instance. So in this setup, what you can do is you can, as I mentioned, with the reuse feature, you can enable a reuse and then define the Kafka container using exact same configuration, same Kafka image version, same configuration. So it won't start two different Kafka instances. It will identify, okay, this current container is using the same configuration that other service is also requesting. So it is going to share the same instance instead of spinning up two different Kafka instances. So reuse will be really helpful in that scenario. Any other questions regarding this? Cool then. So I'm going to share this repository and you can find other interesting links over here. Okay. And if you want to experiment, I would strongly recommend you to clone this and then try this out. And the simply the prerequisites are you need to have Docker and Java installed. And I highly recommend using SDKman. It is really easy to install multiple versions of Java, and you can use any of the Docker container runtime environment like Docker Desktop, Stack, or Podman. So you can install whichever container runtime you prefer, and download this test containers desktop application. And you should have these options to choose from which container runtime to use and all other features. So try it out and let us know. Cool. That's all I have. And so if you have any questions, feel free to add comments to the video. I'll try to address them. Okay, thanks for joining and see you later.